let's look at the types of angles in geometry. Remember that an angle is formed when we have two rays that are connected by vertex. So the vertex would be right here, the point where they meet. This would be one ray, this would be another ray. And this is an angle. So the first type of angle is called a right angle. A right angle is a perfect corner, and you'll often see this little square here which tells you it is a right angle. A perfect corner, and the measure of a right angle, of every right angle, is 90 degrees. And then sometimes you have angles that are narrower than right angles. Any angle that is less than 90 degrees is called acute. Any angle that is narrower than a perfect corner is acute. Okay, so an acute angle might be 2 degrees, it might be 89 degrees, it might be 70 degrees, anything under 90. The third type is called obtuse. So an obtuse angle is going to be wider than 90 degrees. Okay, so 90 degrees would be perfect corner. This is wider. This is a sample of an obtuse angle. Obtuse angles can be 91 degrees up to 179 degrees. Anything greater than 90, but typically less than 180. And that's kind of the hint. The fourth type of angle is actually a line. It is called a straight angle. So every line is actually a straight angle. And a straight angle is 180 degrees. So here are the four types of angles in geometry. Now, oftentimes, angles are formed when we have two intersecting lines. So I'm going to draw two lines here, and let's say they intersect right there. Okay. Here's the center point. I'm going to call this point P. And let's say this is, let's say we have point A right here. And then B, C, and then D. So you can see when we have two lines that intersect, four angles are formed. And we can call these, well, let's number them. We could say this is angle 1, angle 2, this is point P right there, okay? This is angle 3, and this is angle 4. Okay. So what is another name for angle 1? Well, angle 1 would be the same as angle APB. Those would be the same. Angle 2 would be the same as angle APD. Angle 3 here would be the same as angle DPC. And angle 4 would be the same as angle BPC. Okay, so if any of this video is confusing, I encourage you to pause, rewind, play it as many times as you need, because we are talking about a lot of numbers and a lot of letters in this video. Okay, so rewind as many times as you need. So when we're looking at angles, particularly when we have two intersecting lines, there are some relationships for these angles. For example, some angles are adjacent adjacent angles are neighbors. They share a vertex and a common side. So adjacent means neighbors. So angles 1 and 4 are adjacent. They share a vertex, they share a common side, they share a ray. They share ray PB. Angles 4 and 3 are adjacent. Angles 3 and 2 are adjacent. Angles 2 and 1 are adjacent. Neighbors. Another relationship, instead of adjacent, another relationship is vertical. Vertical angles are opposites of each other. Angle 1 and angle 3 are vertical angles. They're opposites. Angles 2 and 4 are vertical angles. Now, related to adjacent and vertical, we have a couple other relationship words. One is called complementary. Complementary angles add up to 90 degrees. So in this sample figure, we do not have any complementary angles. None of these add up to 90 degrees when we pair them up. However, another word is supplementary. Supplementary angles add up to 180 degrees when you add them. In this sample, all of the adjacent angles are also supplementary. For example, if you added angle 1 and angle 2, they form a straight line. Angles 1 and 2 are supplementary. Right, and another relationship you might see is perpendicular. Perpendicular would be when two lines intersect and form perfect corners. So we'll take a look at complementary and perpendicular in a bit. But for now, let's focus on supplementary, okay? So let's see. Clear this out here. So I'm going to draw the same figure. We had a line like this and a line like this. Angle 1, angle 2, angle 3, angle 4. Now, if we are told that angle 1 is 140 degrees, how can we figure out the measure of the other angles? Well, to start with, let's try angle 3. Angle 1 and angle 3 are vertical angles, and vertical angles are what's called congruent. Congruent means equal in measure. The symbol for congruent in geometry is an equal sign with a little squiggly above it. So vertical angles are congruent. So if we know angle 1 is 140 degrees, angle 3 is also going to be 140 degrees. Now, angle 1 is adjacent to angle 4, and angle 1 is adjacent to angle 2. They are supplementary. If we add angle 1 and angle 2 together, they would be 180 degrees. Okay, that would be 180 degrees. And if we added angle 1 and angle 4 together, they would also be 180 degrees, like this. So therefore, if we wanted to solve for angles 2 or angles 4, all we would need to do is subtract 180 degrees minus angle 1, which would be 40 degrees. So angles 2 and angles 4 are both 40 degrees. Okay, because angles 1 and 2 and angles 1 and 4 are supplementary. They sum up, supplementary. They sum up to 180 degrees. So that's how we can do this subtraction. Right? If their total is 180 and this piece is 140, then we can subtract 180 minus 140 to get this piece of 40. So like I said, if this is confusing, feel free to rewind it and rewatch it again. Now, we saw that word earlier called complementary. Complementary is when two angles add up to 90. They add up to a perfect corner. So if we have a perfect corner here, 90 degrees, and we split it into two angles, for example, something like that. This angle right here and this angle right here, these would be complementary. So if this angle right here were 33 degrees, and you wanted to find this angle right here, well, it would be pretty easy. If they're complementary, they add up to 90. So to figure out the yellow, let's just do 90 degrees minus 33 degrees. So 90 minus 33 would be 57 degrees. So the yellow part would be 57. And lastly, we have a particular relationship, or if we have two lines that intersect and they form a perfect corner anywhere. If there is one right angle formed anywhere, then that would be called perpendicular. And anytime you have two lines that intersect, if you see a right corner, you can automatically know that all of the other ones are right corners as well. Okay, because if this is 90, then the vertical angle would be 90. And then the adjacent angles, the supplementary angles, would be 90 as well. So this is a special type of intersection.